Okay, here's the last lecture in the series for Chapter 10, and thank goodness because um, CodeBlocks is running slow, it's been crashing, so I took the opportunity to create this new Lecture10b, and I'll send all these files up on Blackboard. So I erased everything here. I would like you to look at page 579 and 580 at the A2I, A2F, that stands for alpha to int. So you can convert numbers in quotes, like something like this, like, I don't know, 1776. In quotes, it's a string, but how do we get it to its numeric value? Well, you would use alpha to int. Okay, if this was 1776.5, then that would be to float. And then by the same token, if you read in something as a string, you can convert string to alpha. So if you have something that you, or rather string to int, if you have something that comes in from like a text field, it always comes in as a string no matter what language you use, whether it's C++ or Java, or if you're developing mobile apps like on Xcode or Swift or Android, they always come in as strings. You can't do any math on them unless you convert them. So I leave this to you to look at 579 and 580 in the examples. These will not come into play with today's lab, but what I'm going to show you right now does come into play. All right, so we need the string library, obviously. Pound include, now this is string. String is different than C string. This is the string object. So instead of concatenating using string cat and in parentheses, you can actually use the variable name, the dot method, and there you can choose a string concatenation. And that's how I want you to approach the lab that's on Blackboard. So let's create a new string object. I will say string word. How's that for being pretty generic? We have this word. I'm not giving it a size. That size will be determined by what's entered into it. Let's write some code that shows how that we can read this from a user prompt. So I will say something like this: cout, enter a word. Now the nice thing about this is you can enter a word that has spaces in it, like I don't know, like a name like Tommy Lee Jones or United States of America with spaces in it, and this will read it in if you do what I'm going to show you. But for the lab, you're only going to enter a single word with no spaces in it. But what I'm going to show you now has multiple utility for words with spaces. Okay, so the user is going to enter the word. And what you need to do to read that in is you have to use the getLine method. GetLine, first parameter is, where are we getting this from? The keyboard, CN. Where am I going to store it? Word. Okay? And let's say this, cout, you entered word, just to prove that it worked. Okay? Compile. Run. Let me do it. Tommy Lee Jones. Ta-da! It did it. No fuss, no muss. All right. So I just want to enter a single word. I'm going to look for what's called a plosive. Okay. A plosive is a sound you make with lips and teeth pursed, like P's, T's, K, P, T, K. You actually like spit at people. I'm looking for plosives because in your lab you're looking for vowels. So I want to show you how we do this with plosive letters, and then you modify it for looking for A, E, I, O, U, and sometimes Y. All right, it's going to be a function. Pardon me. So the prototype is int find plosive, and we're going to put in some string, and I'll call it WD for word. Okay, so down here, let's look at the prototype. Well, this is the prototype. Let's write this out. What we're going to do is we're going to scan a string and return the first time we see either a P, a T, or a K. So here's the body of the code. Int find plosive string WD. And as you know, this WD does not have to be this. I could call this anything. WRD. It'll still work. It's just, it needs to know that it's got some kind of a placeholder there. All right. Notice I'm not sending in a size. The string array is so powerful, or the string object is so powerful, it knows its own size. So let's create a variable char, and we'll call it letter, LTTR. I want to find that letter and return that position. So, good old for loop. For int I equals 0, I is less than what? How big's the word? I don't know. Well, we do. WRD dot, and there we go. Look at all these methods. Okay, come on, scroll down. You can either use length or size. Totally up to you. Though personally I like length, I'm going to put size in here. Okay, word size. And then, of course, I++. And here's what we're going to do. We're going to grab that letter at that position. What's the position? Well, I is our loop control variable, so we're going to use I to stomp through word. So LTTR will be assigned word dot at, in parentheses, position I, starting from the 0th position up to the size, but not beyond it, or else we'll be having an out of bounds exception. Okay, we'll set it there. And then what I want to do is I want to look for a P, T, or K, uppercase and lowercase. That's 6 comparisons. That's a lot. So you know what? Let's make everything uppercase, and we'll test it in less combinations. So I will say LTTR will be assigned the 2 upper of LTTR. Now, 2 upper is in C string, but it took it. But it doesn't hurt to include, not C string, C type, excuse me, CC type. Now, why was it successful here? Because in some libraries of different compilers, they'll actually include the entire CC type library, but you can't always guarantee that. And it doesn't hurt to put it in twice, because if it's already included in one, it won't include it the second time. But if it's not up here, included in string, and you forget to include it, this line will yell at you. Okay, so now we're uppercase. And how do we test if it's a P, T, or K? If LTTR is equal to an upper P, or LTTR, oops, LTTR, there's no E, please, or LTTR equals an upper T, or LTTR equals the upper K. If it equals any of those, we found it. We found the first plosive. So return I, the position we found it at. Okay, so there we go through the loop. If we get to here and we've not found it, it's a word without any plosives, like, I don't know, moon, M-O-O-N. No plosives are found in that word. Therefore, let's return -1. Because whenever we search an array and can't find something, a negative number, and usually -1, is the number we send, because that will shut down everything and say, oh, we didn't find it. Okay, so we return -1. All right, good. So let's test this word for finding the first plosive. So let's see. How about something like cout the first plosive was found at, uh-oh, look at how slow this is going. He's going to crash. and where? Well, let's output find plosive of the word. Okay, so compile, run it. Moon, no plosive was found. Okay, very good. Run it again. Stop. The first plosive is at position 1, the T. Okay, good. So maybe try one more test just to make sure it's working. That's good software engineering practice. How about something like, let's see, where a K will fall really, really late. So rickety, maybe, found at position 3. Okay, it's working good. All right, I'm going to stop it here because of the slowness, and we'll continue with some other things I want to do with taking strings and breaking them apart. Okay.